The moment I connected both sensors simultaneously and watched them respond in perfect synchronization to my emotional states, I knew I had stumbled onto something profound. The electromagnetic field detector and the galvanic skin response sensor weren't just measuring separate phenomena, they were revealing two sides of the same biological energy system. This is part 3 of our Biofield scanner series, and today I'm going to show you how to build the second crucial component, a galvanic skin response sensor that can detect the electrical changes in your skin caused by emotional and physiological arousal. More importantly, I'm going to share the breakthrough moment when I realized these two simple devices might be detecting aspects of what researchers call the human biofield. Building the galvanic skin response sensor opened my eyes to an entirely different layer of biofield phenomena. While the electromagnetic field detector reveals activity in the space around us, the GSR sensor measures electrical changes happening directly within our bodies. And when you use both sensors together, the results are absolutely mind-blowing. Let me walk you through building the GSR sensor step by step. The core principle is surprisingly simple. Galvanic skin response measures changes in the electrical conductance of your skin, which varies with the activity of your sweat glands. Since sweat gland activity is controlled by your sympathetic nervous system, GSR can reflect changes in physiological or psychological arousal in real time. The heart of the sensor is an operational amplifier, specifically something called a non-inverting amplifier configuration. I used an LM741 op-amp, which costs about 50 cents and is perfect for this application. The op-amp amplifies the tiny voltage changes that occur when your skin conductance changes, making them large enough to drive an LED or be measured with a basic multimeter. Here's how the circuit works. Two electrodes placed on your skin, typically on two fingers of one hand, create a voltage divider where your skin resistance becomes one component. I used a fixed resistor of 100 kiloohms as the other component of the voltage divider. A small, safe voltage from the 9-volt battery is applied across this divider. As your skin conductance changes, which happens when your nervous system increases or decreases sweat gland activity, the voltage across the skin resistance changes. This varying voltage is fed into the non-inverting input of the op-amp, which amplifies it by a factor determined by the feedback resistors. I used a 1 megohm feedback resistor and a 10 kiloohm gain setting resistor, giving me an amplification of about 100 times. The amplified output can drive an LED that changes brightness with your skin conductance, or you can measure it directly with a multimeter for quantitative readings. For electrodes, I started with simple copper-clad PCB material cut into small squares, but tinfoil wrapped smoothly around fingertips works just as well. Building this sensor was actually easier than the electromagnetic field detector because it has fewer components. The op-amp, a handful of resistors, an LED, and the electrodes, total cost under $10. The assembly took about an hour, including time to double-check all the connections. But the real magic happened when I started testing it. The first time I attached the electrodes to my fingers and saw the LED respond to my emotional state, I was amazed. When I took a deep breath, the LED dimmed slightly. When I heard a sudden loud noise, it brightened immediately. When I tried to solve a challenging mental problem, the brightness increased noticeably. This real-time biofeedback was fascinating, but the breakthrough came when I used both sensors simultaneously. I set up the electromagnetic field detector near my other hand while wearing the GSR electrodes, and I started introducing various stimuli to see how both sensors would respond. The results were extraordinary. When I listened to calming music, both the electromagnetic readings and the skin conductance readings decreased together. When I heard a startling noise, both sensors showed immediate increases in activity. During mental tasks like arithmetic problems, both readings elevated simultaneously. But the most remarkable discovery came during an experiment I conducted with guided meditation. I found a 20-minute progressive relaxation audio track and monitored both sensors throughout the entire session. As I relaxed deeper into the meditation, Both electromagnetic activity around my body and my skin conductance decreased steadily and proportionally. This wasn't just correlation. The timing was so precise that it suggested both phenomena were being driven by the same underlying nervous system activity. When my sympathetic nervous system activated due to stress or arousal, both electromagnetic emissions and skin conductance increased. When my parasympathetic nervous system took over during relaxation, both measurements decreased. This observation aligned perfectly with Biofield research suggesting that electromagnetic activity around living organisms might be directly connected to autonomic nervous system function. Some studies propose that the biofield is essentially the electromagnetic signature of our nervous system activity extending beyond the physical boundaries of our body. I started testing this hypothesis more systematically. I created simple emotional stimuli, calming music, nature sounds, sudden noises, challenging puzzles, and carefully monitored both sensors during each condition. The correlation was consistent and dramatic across all test conditions. Even more fascinating was what happened when I tested other people. Just like with the electromagnetic detector alone, different individuals showed vastly different baseline readings and response patterns on both sensors. Some people had highly reactive GSR and strong electromagnetic signatures. Others showed minimal responses on both measurements. But here's what really convinced me that we might be detecting aspects of an integrated biofield system. The people who generated the strongest electromagnetic fields were almost always the same people who showed the most reactive galvanic skin responses. Conversely, individuals with weak electromagnetic signatures typically had less responsive GSR patterns. This correlation suggested that both measurements might be reflecting individual differences in overall nervous system reactivity or biofield strength. Some people seem to be naturally more electromagnetic active and physiologically reactive, while others operate at much lower baseline levels on both measures. The implications started hitting me all at once. If biofield phenomena are real and measurable, they might represent the electromagnetic aspect of nervous system activity that extends beyond our physical boundaries. The biofield might not be some mystical energy separate from known physiology. It might be the electromagnetic signature of our nervous system that we can now detect and measure with simple, inexpensive devices. This realization changed everything about how I understood both the technology and the phenomena we were detecting. These weren't just electronic toys or pseudoscientific gadgets. They were legitimate biofeedback devices that could reveal aspects of nervous system function that are normally invisible to us. I started experimenting with using both sensors as training tools. By watching the real-time feedback, I could learn to voluntarily influence both my electromagnetic emissions and my skin conductance through breathing techniques, meditation, and mental state control. It was like having a window into my own autonomic nervous system. The biofield scanner was no longer just a detection device. It had become a training system for developing conscious control over normally unconscious physiological processes. I could literally watch my biofield activity change in response to my thoughts, emotions, and intentions. But this discovery also raised profound questions about the nature of consciousness and its relationship to electromagnetic fields. If our thoughts and emotions can influence measurable electromagnetic activity around our bodies, what are the implications for how consciousness might interact with the physical world? The more I experimented with both sensors, the more I realized I had only begun to scratch the surface of what this technology might reveal. The combination of electromagnetic field detection and galvanic skin response measurement was providing a crude but functional window into biofield phenomena that researchers are only beginning to understand. In Part 4, the final installment of this series, I'm going to share the most advanced applications I've discovered for biofield detection technology. I'll show you how to expand these basic sensors into a complete biofield monitoring system, and I'll reveal the shocking experiment that convinced me we're on the verge of a revolution in our understanding of human energy fields. More importantly, I'll share my vision for where this technology is heading and how you can be part of the research community that's pushing the boundaries of biofield science. The future of energy detection is in the hands of curious individuals like us, and what we discover next could change everything.